guys, in this video I'm going to continue solving linear equations. I'm going to start with this question right here. I have negative 6 times the quantity in parentheses b minus 4 is equal to 42. And so again, we're looking for the value of the variable that will make this equation true. So in this case, our variable happens to be b. And so we want a value for b that will mean that the left-hand side of my equation is equal to the right-hand side of my equation. So as before, what we really want to do is we want to isolate the variable. That means get the variable by itself, again, probably on the left-hand side, since it's already on the left-hand side, and then have everything else on the other side. So order of operation, this means that inside the parentheses I have b minus 4, and I have this quantity b minus 4 times negative 6, so I've got to deal with this negative 6 first. The way I do that is I'm going to divide both sides by negative 6. So if I divide the left-hand side of my equation by negative 6, of course, whatever I do to the left, I must do to the right, so I must divide this side by negative 6. Here, my negative 6 will cancel, and I'll be left, therefore, with the quantity b minus 4. I will now remove the parentheses because it's by itself. B minus 4 is equal to 42 over negative 6. Well, what's that? Well, I have a positive number divided by a negative number, so I know it's going to be negative. 42 divided by 6 happens to be 7. So the answer is negative 7. Not quite done. I have b minus 4 is equal to negative 7. I want b, so what am I going to do? To get b by itself, I'm going to add 4 to both sides of the equation. I have to add 4 to this side to get b by itself, and of course, whatever I do to here, I do to here. And so I end up with b is equal to minus 7 plus 4. I've added 4 here, and then it's gotten rid of my negative 4 on the left-hand side. And so I have that b is equal to minus 7 plus 4, that's negative 3. And that, in fact, is my answer. I could even just sort of check it real quick if I want. If I input negative 3 in here for b into my original equation, I will get negative 6. Put it up here, negative 6 times negative 3 minus 4. Minus 3 minus 4 is minus 7. And minus 6 times minus 7, a negative times a negative is a positive. 6 7 is 42. And so sure enough, I find that 42 is correct. 42, I get 42 on the left-hand side of my equation, I have 42 on the right, so I know I got the right answer. All right, let me put up a question for you to try yourself. That is similar in nature to the one we just did. Try this one, please. That would be 3 on z minus 1 is equal to 18. So the variable in this case is z, so I'm looking for a value for z that will make this statement true. Again, that's 3 times the quantity z minus 1 is equal to 18. Try that one yourself, please. All right, I want to try now a problem in which I have a variable on both sides of the equation. So I have a variable on the left and the same variable on the right. How do I solve that? All right, so let's try the following. I have minus x plus 3 is equal to, this is my equation, 5x plus 63. Again, I'm looking for a value for x that will make this statement true. How do I go about that? What I'm going to do is very similar to what we've done before. I'm going to bring all my x's to one side. I want to isolate that x. So in order to isolate my x, I'm going to bring my x's to one side of the equation. Let's just bring it to the left-hand side. So in order to, I have a 5x on the right-hand side. And so in order to bring that, as it were, over, what I'm going to do is I'm going to subtract 5x from both sides of this equation. That will bring my x's to the left-hand side of the equation. I will have here a plus 3 on the left-hand side. I want that, because it doesn't have any x's in it, so I don't want it to be over here on the left. I want that to be on the right-hand side. And so in order to bring that over to the right-hand side, I'm going to subtract 3 from both sides. I'm going to subtract 3 from both sides of the equation. And so I will end up with, I have a minus x here on the left. I subtract 5x from both sides. So I subtract 5x from both sides. I'm subtracting it over to the other side, if you like, is equal to, I have a 63 on the right. My 5x is no longer there, it's on the other side. And I have subtracted 3. I need to subtract 3 from both sides. So I have minus 3. So I have, my 3 is no longer here. Again, if you like to think about it that way, I've subtracted 3 from the left-hand side to the right-hand side. And so I can now, I have all my x's on the left and all my constant values, all my numbers on the right. And so bringing them together, I have x minus x is minus 1x minus 5x. It's minus 6x is equal to 63 minus 3 is 60. And so to get x by itself, I've seen this a few times now, I'm going to just simply divide this quantity by minus 6 and do the same to this side. And so I will get x is equal to 60 divided by minus 6. 60 divided by minus 6, well, positive over negative, that's negative. 60 divided by 6 is 10. And so x is equal to 10. That is my answer. X is equal to 10. All right, let me give you one to try. So try this one yourself, please. 7x minus 4 is equal to 8 plus x. 8 plus x. So please try that one yourself. 7x minus 4 is equal to 8 plus x. We're looking for the value of x that will make that statement true. And I want you to solve the equation. A way of saying the same thing. All right. All right, so let's have a look at a different kind of problem. Here I have, it is again a linear equation. 3 times the quantity 7x minus 6 is equal to 21x plus 2. 21x plus 2. All right, we want to solve this equation. Here I have a 3 times in parentheses 7x minus 6. In order to deal with this, what I'm actually going to do is I'm going to distribute my parentheses. Right? So I'm going to distribute this 3 into my parentheses. So 3 times 7x, 3 times 7 is 21, so 3 times 7x is 21x. So this is 21x. 3 times negative 6 is minus 18, is equal to 21x plus 2, 21x plus 2. And now, what I can do is I can subtract 21x from both sides. All right, so I have 21x minus 18 is equal to 21x plus 2. If I subtract 21x from both sides, I will have 21x minus 21x. Well, that leaves me with negative 18 is equal to 21x minus 21x. It will cancel. I'll be left with 2. So if I subtract 21x from both sides, I'm left with negative 18 is equal to 2. Wait a second, negative 18 is equal to 2. That makes no sense. This is not possible. When is negative 18 equal to 2? The answer is never. Negative 18 is never equal to 2. And so this original problem here, this original equation, has no solutions. So this linear equation has no solutions, and that is perfectly possible. It is possible to have a linear equation that does not have solutions. All right? So be on the lookout for that. That is a possibility. All right, let's try a different problem. Let's try the following problem. 3 times 7x plus 14 is equal to 7 times 3x plus 6. All right, that's our linear equation, and we're asked to solve it. All right, so what is the value of x that satisfies this equation? So again, we want to isolate our x. Going to distribute in my 3 here, here. 3 times 7 is 21, so again I have 21x, just like last time, plus 3 times 14, that happens to be 42, is equal to 7 times 3, that's 21, 21x, and 7 times 6 is 42. And look what I have. I have 21x plus 42 is equal to 21x plus 42. If you wanted to be consistent with what we've done before, I can subtract 21x and I can maybe subtract 42 from both sides. Right? So if I subtract 21x from both sides, I will have 0. I subtract 21x. And if I subtract 42 from both sides, I'll have 0. And so I'll have 0 here and 0, and I will end up with 0 equals 0. This equation, this original equation here, is true for all real values for x. All real values of x satisfy this original equation. This equation is what we call an identity. It is, the original equation is an identity. Notice that what I have here on the left-hand side of my equation, when I distribute in my 3 and I distribute in my 7, what I end up with on the left-hand side equation is exactly the same as what I end up with on the right-hand side of my equation. And so you will end up, if you try to isolate your x like we have done before, you will end up with 0 equals 0, which is of course true, but like I said, this is true not for just a particular value of x, but in fact for every value of x. And so the term for this type of an equation is an identity. This is what we call an identity. And so this ultimately means is that there are 3 possibilities when we have a linear equation. We can have one unique solution, like what we have seen in the previous video, and today in fact. We can have no solution. The linear equation may have no solution, like we just saw, or in fact, you can have an identity, that the equation is true for all real values of x. You can put in any value of x, any real value you choose in for x, and this equation will hold true. So like I said, this term here that we're using and that we use in algebra is an identity. All right. Okay, so let's finish this problem today, this video, with a problem, a word problem. All right, so we'll finish with a word problem. And that word problem is the following. We have a rectangle. I'll write it out. We have a rectangle that with a length that is 4 centimeters shorter than its width. The question is, what is, or find the length and the width. All right, so this is what we're asked. We're given this piece of information. Rectangle had a length that is 4 centimeters shorter than the width. Find the length and the width. We are given, of course, one very crucial piece of information. We're told the perimeter. The total perimeter, couldn't do the question without this piece of information. The total perimeter is 100 centimeters. Total perimeter is 100 centimeters. Okay, so how do we find our length and our width? Well, what I'm going to do is I'm going to assign a variable to my length and my width. So let's just draw the triangle here, something like that. So my length here, let's call this the length, sorry, I'll call this here the length. So this here will be my x, and my width, well, I'm told that the width is 4 centimeters longer than the length. And so in this case, this will be my width. This here will be x plus 4. It being a rectangle, we know that this distance here is also x, and this distance here is also x plus 4. So I have x, x plus 4, x, and x plus 4. And so what it means, I'm going to just erase some of this board here so I have the board space. What it means is that my perimeter is x plus 4 plus x plus 4. And we know that that perimeter is equal to 100. If we gather up our like terms here, I have x plus x plus x plus x, that is 4x, x plus x plus x plus x, and I have plus 4, that's plus 8. So 4x plus 8 is equal to 100. And so now I have just a simple linear equation, the likes of which we've seen many times now at this point. In order to isolate my x, I'm going to start by subtracting 8 from both sides. And so I have 4x is equal to 100 minus 8. So therefore 4x is equal to 100 minus 8 is 92. 92. Almost there. 4x is equal to 92. In order to get x by itself, I'm going to divide both sides by 4. Right? If I divide 4x by 4, I'm left with x is equal to 92 divided by 4. And if I'm not mistaken, that is 23. And so I have x is equal to 23. And that, therefore, is my length. The length of my rectangle is 23. So my length is equal to 23 centimeters. And my width, I know my width is 4 centimeters longer than my length. And in that case, that's 23 plus 4 is 27. And so my width is 27. If I wanted to just check it real quick, what I could do is I could just verify that 23 plus 27 plus 23 plus 27, that is this distance plus this distance plus this distance. This should be equal to 100. So this is 23 plus 27, that is 50. Plus 23 to 27 is 50, and sure enough, that is 100. And so these values are correct. All right, so just a nice little word problem to finish off the video. All right, so that's it for this one. See you next video.